Hello, my name is Alifbana. My matrix number is PI241104002. And my role is the system architect, the thread developer, and the synchronization engineer. So my task is to design the synchronization model and diagrams and implement how threads behave and execute in the system and implement mutex and semaphore logic. Now to the code. So this is the thread module, the thread management module. So this is where the thread are created and managed. So in our implementation, we created 4 reader threads and 2 writer threads. And each reader threads execute the reader lifecycle function. And each writer thread, it execute the writer lifecycle function. So in this module, the thread are created using the pthread underscore create function. And the main program waits for all the threads to finish before the threads use this function. And to execute concurrent execution, to simulate concurrent execution, we added random delay so that the reader and writer are random every time the system execute. And after everything is finished, the system does a cleanup and it terminates safely. So now to the synchronization engine. So the mutex, it is created to protect the read count. The read count is to see how many active number of readers that are active at that time. And the semaphore is to control the access to the shared file and make sure that writers, they can only be one writer at one time. So the init sync is to initialize the synchronization. So when a reader enter, it has to obtain. So when the reader enter, the read count is increased, and the reader must obtain the semaphore so that the writer cannot access. And but other reader can access. If the first reader, then they obtain the semaphore. And when the reader finish, and if they are the last reader and they want to exit, they release the semaphore and the read count decrement. And then for writer, uh, when they enter the system, they must obtain the semaphore. So this can block another writer and reader from entering the system. And this guarantee them having exclusive access. And when the writer complete the operation, they release the semaphore and let the system continue. And now we run the system, the compile system. As we can see, uh, reader 2 is reading, and then reader 4 is reading, and then reader 3 is reading, and then reader 1 is reading. So they are reading concurrently, and after they all finish reading, and then the writer can access. And the writer can only one writer can access at one time. So they must finish before either writer can enter. That's all from me.
Hello, my name is Najwan. Cassius, no matrix, BI 241104003. I'll explain about the file access layer code. Um, from this code, you can say that um, the code initialize the shared file and fopen create or open the file. Fprint f writes the initial content and fclose the file to prevent resource leaks. Okay, moving on to the reader function code. The function starts by calling readInter, which checks synchronization rules before accessing the shared resource. The file is opened in read mode using fopen. Fgets reads the file content into a buffer and fclose the file. Finally, reader exit updates the reader count and release access if this is the last reader. Moving on to the writer function. For this code, the writer first calls writer_inter to obtain exclusive access. The file is opened in append mode, so new data is added without deleting existing content. Fprintf writes the message into the file. After writing, the file is closed and writer exit release the semaphore for other threads. Next, for logging system code. For this, the mutex is initialized to protect the log file from concurrent access. The log file is then opened so all system events can be recorded. For the main logging function, the mutex log ensures only one thread writes to the log at a time. Fprintf writes the log entry, fflush immediately saves it to the disk, and the mutex is unlocked so other threads can continue. For thread event logging, this function records thread activities. It automatically includes the thread ID, thread type, and activity description to make debugging easier. Now let's see the output for the test runner. We'll paste it in the terminal. Let it run. So this is the output. One reader can access concurrently. Test 2, writer have exclusive access. Test 3, mixed reader and writer. And then stress.